Okay, we can estimate values of our x, which correspond to the cosine, and y, which correspond to the sine, for the various angles around the circle. The angles being 0 here, around to 2 pi radians here, or alternatively 0 around to 360 degrees here. Meaning that we go from 0 to pi over 2 radians in the first quadrant, and 0 to 90 degrees in the first quadrant. So we're just going to estimate the angles in the first quadrant just to get the idea that we can make these estimates and we should make these estimates. Okay, so just quickly estimating that we break the first quadrant into about 5 more or less equal segments. We went a little past the end of the first quadrant here, and this segment is bigger than these segments toward the end, so we're not going to be great with our accuracy, but still just assuming this, we estimate that we've gone through an angle of about 95 degrees in 5 segments, making the angles, if the angles were equal, 0, 19, 38, 57, 76 degrees up to this angle. And also that we've got 20 of these around the circle, and they come up just a little shy of the end of the circle, meaning that this is going to be close to 2 pi radians, but a little less. 2 pi 6.28, a little less than that is 6. That's very plausibly 6 radians. So we've got about 0.3 radians for every one of these divisions. But these divisions are a little bigger, so we estimate 0.32, and we also estimate that in another way per division anyhow. So we have the angle theta, 0.32, 1.3. Those are the angles. These are the angles as measured in degrees. Remember, degrees is not our default measure of angle. Radians is the default measure. We estimate the x-coordinates and the y-coordinates. X-coordinates go from 1 down to 0, and made these estimates. Okay, those aren't really good estimates, but those are the estimates I made based on this hand sketch. My projection lines aren't all that horizontal or vertical or straight or anything. Y-coordinates, maybe here at this point about 0.35, about 0.65, 0.85, 0.95. So these are the coordinates. We kind of confirm these coordinates, or at least get some idea how accurate they might be, noting that for any of these points I can sketch a right triangle whose vertical leg is the y-coordinate, whose horizontal leg is the x-coordinate, and whose radius is the radius of the circle. Now again, we've assumed a equals 1, so the radius is 1, so the square of this plus the square of this should equal 1. When we calculate the sum of the squares, we get numbers from about 0.93 up to about 1.1. Those are reasonably okay. Good estimates would come out somewhat closer. Also note that our estimates of these values, if we confirm them by actually calculating them using a calculator, spreadsheet, or whatever, are usually within plus or minus 0.05 of the correct values. So they aren't really bad estimates, but they aren't great estimates. And I've recommended that you calculate these in degree or radian mode as appropriate. Do the degrees, calculate. Do the radians, calculate. See how close they are. Then check the actual values, as I just said. And then draw your own circle, subdivide it, make your own estimates, and compare. How accurate can you be? Now, I would recommend maybe subdividing each quadrant into equal segments and then subdividing each of those into equal segments. You can do that more accurately than you can trying to keep a consistent distance between the points. In any case, useful exercise, and I do recommend it.